live in a three-dimensional world where everything has length, width, and height. But what if our world were two-dimensional? We would be squashed down to occupy a single plane of existence, geometrically speaking, of course. And what would that world look and feel like? This is the premise of Edwin Abbott's 1884 novella, Flatland. Flatland is a fun mathematical thought experiment that follows the trials and tribulations of a square exposed to the third dimension. But what is a dimension anyway? For our purposes, a dimension is a direction, which we can picture as a line. For our direction to be a dimension, it has to be at right angles to all other dimensions. So a one-dimensional space is just a line. A two-dimensional space is defined by two perpendicular lines, which describe a flat plane, like a piece of paper. And a three-dimensional space adds a third perpendicular line, which gives us height and the world we're familiar with. So what about 4 dimensions, and 5, and 11? Where do we put these new perpendicular lines? This is where Flatland can help us. Let's look at our square protagonist's world. Flatland is populated by geometric shapes ranging from isosceles triangles to equilateral triangles to squares, pentagons, hexagons, all the way up to circles. These shapes are all scurrying around a flat world, living their flat lives. They have a single eye on the front of their faces, and let's see what the world looks like from their perspective. What they see is essentially one dimension, a line. But in Abbott's Flatland, closer objects are brighter, and that's how they see depth. So a triangle looks different from a square, looks different from a circle, and so on. Their brains cannot comprehend the third dimension. In fact, they vehemently deny its existence because it's simply not part of their world or experience. But all they need, as it turns out, is a little boost. One day, a sphere shows up in Flatland to visit our square hero. Here's what it looks like when the sphere passes through Flatland from the square's perspective. And this blows his little square mind. Then, the sphere lifts the square into the third dimension, the height direction where no Flatlander has gone before, and shows him his world. From up here, the square can see everything. The shapes of buildings, all the precious gems hidden in the earth, and even the insides of his friends, which is probably pretty awkward. Once the hapless square comes to terms with the third dimension, he begs his host to help him visit the fourth and higher dimensions. But the sphere bristles at the mere suggestion of dimensions higher than 3 and exiles the square back to Flatland. Now, the sphere's indignation is understandable. The fourth dimension is very difficult to reconcile with our experience of the world. Short of being lifted into the fourth dimension by a visiting hypercube, we can't experience it. But we can get close. You'll recall that when the sphere first visited the second dimension, he looked like a series of circles that started as a point when he touched Flatland, grew bigger until he was halfway through, and then shrank smaller again. We can think of this visit as a series of 2D cross-sections of a 3D object. Well, we can do the same thing in the third dimension with a 4-dimensional object. Let's say that a hypersphere is the 4D equivalent of a 3D sphere. When the 4D object passes through the third dimension, it'll look something like this. Let's look at one more way of representing a 4-dimensional object. Let's say we have a point, a 0-dimensional shape. Now we extend it out 1 inch, and we have a 1-dimensional line segment. Extend the whole line segment by 1 inch, and we get a 2D square. Take the whole square and extend it out 1 inch, and we get a 3D cube. You can see where we're going with this. Take the whole cube and extend it out 1 inch, this time perpendicular to all 3 existing directions, and we get a 4D hypercube, also called a tesseract. For all we know, there could be 4-dimensional life forms somewhere out there, occasionally poking their heads into our bustling 3D world and wondering what all the fuss is about. In fact, there could be whole other 4-dimensional worlds beyond our detection, hidden from us forever by the nature of our perception. Doesn't that blow your little spherical mind?